Hi, this is my CPR for exam one. Um, I'll first be talking and explaining kind of the concepts behind electrical potential, and then I will go through a computation of the problem from exam one. So first to start, a little background. The electrical potential between points is actually an abstract number at every point in space. And so electrical potential can be pretty much compared to gravitational potential energy. You can only measure the distances between 2 points. So the concept of electrical potential is actually very similar to other topics covered in physics, such as velocity. In order to compute velocity, you need a reference point to compare its motion to. The same can be said for gravitational potential energy. So looking at potential energy, I have two people here, one on a boat and one on the sea floor. So the person standing on the boat, if he was going to refer to his potential energy, he would probably say that his zero potential energy would be right here at the sea level. Now we see the person on the bottom floor, they would probably say that their potential energy will be here. There's zero on the bottom of the seafloor. And so you say, okay, so which one's correct? Well, technically both are correct because you can't find the zero of potential energy. You can only determine potential energy based off differences. So you could compute the amount of work it takes this person to swim up to the boat. You could also compute the kinetic energy this person would receive. So if he jumped in and sank all the way to the bottom, you can compute his kinetic energy down here. These two values will actually be the same. So from this example, you can kind of see that electrical potential can only be solved for between 2 points. You need at least a reference point. And so now we're going to go into an example from exam one. This question is asking, so there are 4 -1 NC charges at the corners of a cube, and these are all located at, you can see here on the graph. And so it's asking how much work does it take to move a -2 coulomb charge from infinity to square root of 2 meters, square root of 2 meters. So the first thing that we will need to do is identify the point where we are finding the electrical potential. So that will be right here in the middle of these 4 charges. And so we're actually going to compute the distance between these 4 charges and the electrical potential. So this would be R3, this would be R2, R1, R4. And so you can see that this point is actually equal distance away from all 4 of these charges. So if we compute the distance right here, this R3, this R4, all these are the same values. If we compute this, you can make a little triangle here. So we know the value of 2 sides are both going to be the square root of 2. So given 2 sides of a right angle triangle, we can see that R1, R2, R3, and R4 will all be equal to 2 meters. And so we need to do this because we are computing for a charge that's not placed at the origin. So we're going to need this R value, and I'm going to call this R prime, but we're going to need this R value later. So next we're going to need to find the equation for electrical potential away from the origin. So we know that electrical potential is equal to the charge over 4 pi epsilon R squared AR. So now that we're finding the electrical potential between VR prime and V infinity, we need to take the negative integral from infinity to R prime of Q over 4 prime epsilon R prime squared dr. And so we can see, if we simplify this a little bit further, we can see that to compute for a point charge that is not at the origin, it will be this q point charge over 4 pi epsilon r prime. And so this equation is the amount of work it takes 1 coulomb of charge to move from v infinity to r prime. So it's not dependent on the origin. So now that we have that equation set up, we can plug in our values. So we have v r prime is equal to v, minus, should be a minus, v infinity is equal to q over 4 pi epsilon r prime. And I'm just going to separate this a little bit further. So it'll be 1 over 4 pi epsilon, which the value is given, which is 10 to the negative 9th over 36 pi. And this is farad meters. And then this will be times that q, which is equal to negative 10 to the negative 9th. This is in coulombs, over r prime, which is equal to 2 meters. And since there are 4 charges, we will need to multiply this by 4. So for solving for that equation, we get negative 18, and you can see that 1 farad is equal to 1 coulomb volt. So solving for volts, we can get this value actually be volts right here. And so this is negative 18 volts. And this is the potential, the electrical potential for a 1C charge to move from V infinity to R prime. So we need to find now how much work it takes to move a negative 2C charge. So first, I'm going to convert this negative 18 volts. You can see the energy in joules is equal to volts times the electric charge, which is C. Just divide by C here. And so we can see the negative 18 volts is equal to negative 18 joules per coulomb. So we're going to take negative 18 joules per coulomb times the negative 2C charge. And we see that it takes 36 joules of work to move a negative 2C charge from infinity to square root of 2, square root of 2, 0. All right. Thank you.